everyone, and welcome. Today, we're going to do a developer's deep dive into one of the most powerful techniques out there for really taming large language models: reinforcement learning from human feedback, or RLHF. You know, if you've ever wondered how models like ChatGPT go from just predicting the next word to being genuinely helpful and aligned, well, RLHF is the secret sauce. So let's get into it and break down how it all works.
So imagine this. You've spent all this time fine-tuning your LLM. It can answer questions, it follows your instructions, but here's the real question. Is it actually any good? Does it give you outputs that people find helpful or harmless or, nuanced? And that right there is the core problem RLHF is built to solve. It's all about bridging that gap between a model that's just technically correct and one that's genuinely aligned with what we as humans actually prefer.
So if you're a developer, this really comes down to a practical choice. On one side, you've got supervised fine-tuning, or SFT. You can think of this like giving the model a giant textbook with all the correct answers. It works, sure, but trying to create a data set that covers every single little nuance is unbelievably expensive, and you run a huge risk of overfitting. But then on the other side, you have RLHF, and it brings a totally new approach to the table. Instead of learning from a static pile of correct answers, the model learns from a live, dynamic stream of human preferences. This is way more scalable and honestly a much more cost-effective way to get to true alignment.
All right, so here's the game plan for today. We're going to start by really understanding the limits of SFT, why we need something more. Then, we'll get into the real nuts and bolts. We're going to build the RLHF process from the ground up. First, we'll build a judge, which is our reward model. Then we'll use that judge to optimize our LLM. After that, we'll look at the whole pipeline in action and wrap things up with some practical, real-world tips and tools to get you started.
Okay, first up, to really get why RLHF is such a big deal, we have to talk about the classic approach that it improves upon: supervised fine-tuning. Let's dig into the limitations you hit when you're just relying on static, pre-labeled data. So here you can see the standard SFT process. And the key thing to notice is that it's basically an offline one-shot deal. You've got this fixed data set of prompts and their so-called correct completions. You just train the model to mimic this data. The problem, of course, is that the real world isn't a fixed data set. This static approach usually creates a model that's pretty good at memorizing answers, but not so great at generalizing to new prompts it's never seen before. And that right there is the heart of the problem for any developer. If you want to create a model that is truly helpful and safe across millions of different scenarios, you would need an SFT dataset of just astronomical size. I mean, we're talking about millions of high-quality, human-written examples. The cost and the time to create something like that, it's just not feasible. We need a smarter, more scalable way to teach the model what we prefer. And that smarter way begins right here. This is our first practical step in the RLHF process. We are going to build a judge, an AI model that actually learns to think like a human reviewer and score outputs based on our preferences. This is what we call the reward model. So, how do we actually build this judge? Well, it's a surprisingly straightforward three-step process. First, you take a prompt and have your current model generate a few different answers. Easy enough. Second, you show these responses to actual people and just ask them to rank them from best to worst. And think about it, this is so much faster and cheaper than asking them to write a perfect answer from scratch. And finally, you take all that ranking data and use it to train a new model, the reward model, whose only job is to predict how a human would rank any given response.
So let's be really clear here. The reward model isn't learning to write text. Its one and only job is to learn a super simple rule. If you give it two responses to the same prompt, it needs to assign a higher number, a higher score, to the one that humans liked better. That's it. It's a really simple concept, but it is the absolute foundation of the entire RLHF pipeline. Now for a more technical definition. The reward model is usually just a copy of your base language model, but the key difference is we perform a little surgery on it. We rip out its final layer, the one that predicts the next word, and we replace it with a new one. This new layer is designed to output just a single number, a scalar score, that represents how much a human would probably like that response. Okay, so we've built our judge. Now it is time to put that judge to work. In this next step, we're going to use our reward model to actively coach and improve our original language model, and we're going to do it using reinforcement learning. First, a quick terminology check, because you're going to hear this a lot. In the world of reinforcement learning, the model you're training is called the policy. So for us developers, the policy is simply our large language model. And its actions, well, those are just the words or the tokens it decides to generate, one after another, to create a response. Okay, this is where the magic really happens.
We take a prompt and our policy, the LLM, generates a response. We then feed that response over to our reward model, and the reward model gives it a score. The whole goal of the reinforcement learning algorithm, which is almost always Proximal Policy Optimization, or PPO, is to just slightly tweak the LLM's internal weights so that the next time it sees that prompt, it's more likely to generate a response that gets an even higher score.
But there is a huge danger here, and it's called reward hacking. The model could figure out that some nonsensical gibberish actually gets a really high score from the reward model. So to stop this from happening, we add a critical guardrail. It's a penalty that's calculated using something called KL divergence. Now, all that does is it measures how much our new fancy model has changed from the original one. This penalty basically stops the policy from wandering off into crazy town, making sure we get responses that are both aligned and coherent.
And hey, don't just take my word for it. Researchers have found that this KL penalty isn't just a nice to have, it is absolutely critical for keeping the PPO training process stable, especially when you're scaling up to bigger models and longer training runs. It is a key piece of the puzzle if you want to implement this successfully.
Okay, so we've looked at the individual pieces, right? We have the policy and we have the reward model. Now let's zoom out and see how they all fit together into one single dynamic training loop.
Let's just walk through this loop because it shows you exactly how this works in an online system. Starting at step 4, the model that's out in the wild, our policy, generates a response. Next, at step 5, that response gets sent over to our reward server. At step 6, that server calculates a score. And finally, at step 7, that score is used as a signal to update the policy's weights. This entire loop just runs over and over, allowing the model to constantly learn and get better.
So when you boil it all down, this is the core difference. SFT is static and offline. You train your model once on a fixed data set and you're pretty much done. RLHF, which is a type of reinforcement fine-tuning, or RFT, is online and dynamic. The model is in this constant state of learning, always adapting based on that reward signal. For you, as a developer, this means you're building a system that can actually evolve and improve over time.
All right, let's get super practical now. We've covered the theory. So what are the actual challenges you're going to face when you try to implement this, and what tools can you use to get started?
First, a little heads up on the common gotchas. PPO itself, it can be a real pain to train, so definitely start with proven libraries and settings. Reward hacking is a constant threat, which is why that KL penalty we talked about is so important. And remember, garbage in, garbage out. Your final model is only ever going to be as good as your human feedback, so you need to invest in clear guidelines for your annotators. And finally, just be ready for the compute cost. A full RLHF setup means juggling multiple models all at once, so you gotta be smart about your engineering.
Now, the good news is you do not have to build all this from scratch. There are some fantastic open source libraries that handle a ton of the complexity for you. Hugging Face's TRL is a great place to start. TRLX is a version of that designed for even bigger models, and RL for LMs gives you a whole bunch of different RL algorithms to play with. These are really your best entry points into the world of RLHF.
And that brings us to the end. Look, RLHF is an incredibly powerful tool. As developers, it gives us the ability to align models with human preferences, to move beyond just predicting text and create AI that's genuinely helpful. But all that power also gives us a pretty profound responsibility. The question isn't just how we align our models anymore. The real question is, whose values are we choosing to align them with? And that is a challenge that goes way beyond the code. Thanks for watching.